One this is MLOps series. In this we'll take you through complete MLflow framework in depth. This is the first video of the series, and you can take this as an introduction to upcoming series. Before we talk about MLflow, let us talk about machine learning workflow. Machine learning is not just about creating a model, but it involves a series of tasks that we call it as a machine learning workflow. So here you can see uh, inside this workflow, the preliminary step is the retrieving of the data from different sources, and then store it in a centralized repository, and then from there we approach into clean the data and then explore that particular data, and then finally we prepare that particular data or transform the data to a required a form, and from there we inject that particular data to develop the model and then train that particular model. Once we have the model in place, then we validate and then evaluate the model. So once we are satisfied with the evaluation metrics, we push that model into production, and that's not the end of life. We should keep on updating this particular model with the upcoming latest data. So for which, like, we will introduce some monitoring mechanism, and finally we update it, and this workflow continues uh, day on day. So let us take an example, um, where you are trying to train a particular model, and then let's say you have a model with some kind of evaluation metrics, but you're not satisfied with those metrics. So what you do, you change the parameters again, you retrain the model with the same kind of data, and then assume that you arrived at some better evaluation metrics, but still you are not satisfied, and then again you fine tune few more parameters, and then again you retrain the process or you rerun the process such that, like, you achieve the evaluation metrics or the validation metrics that are very much required by you or your organization. So what happens is, as and when you are retraining and then you are evaluating and then evolving the model from better to the best, all the previous iteration metrics are lost. This is the major pain point every data scientist or a machine learning engineer go through day in day out. So this is the basic point where this MLOps is trying to address. So how do you keep track of the process that you are actually carrying in your daily life or day-to-day activities? So that is where a lot of frameworks started evolving to support data scientists and machine learning engineers to keep track of this particular machine learning workflows. So out of those frameworks, MLflow is one such framework. So MLflow basically is an open source platform for managing and tracking machine learning workflows. Basically it is developed by Databricks, and MLflow is designed to help data scientists and machine learning engineers with various tasks such as experimentation. Basically experimentation is creating your models and all. In MLflow terminology we call that as experimentation, and moreover MLflow also gives you the capability of reproducibility and deployment of machine learning models into staging, production, or different environments. MLflow is not only the framework that is available in the market out there, but there are other frameworks that are also available to support this concept of MLOps. Couple of things are like Kubeflow, which is strongly supported and backed by Google community, Apache Airflow by the Apache community, and of course MLflow by the Databricks community. MLflow integrate with lot of technologies, and let me show you them. This is basically the MLflow website. So the technologies that are integrated strongly with MLflow is basically this one. So you have TensorFlow, PyTorch, Keras, Spark, Scikit-learn, Hugging Face, DagHub. So lot of things are there which go seamlessly and integrate with MLflow. And not only that, but MLflow is strongly supported by the organizations like Databricks, Microsoft, R, Facebook, DagHub, and different things. You can see it, you can just visit MLflow org website, and you can get all these supporting technologies and organizations. With that introduction, let me go through a bit with the components that are actually a core part of MLflow. There are 4 different components: MLflow tracking, MLflow projects, MLflow model, and MLflow registry. So MLflow tracking is the core part or the crux of MLflow, where you can record, you can save different parameters, different data, different metadata, different results, different models that are the outcomes of every iterations that you do in an experiment. And coming to MLflow registry, it's actually a central part where you can actually save your models, and then finally from where you can actually serve them. ML models, as I said, it is the central part where the model gets served from that particular area. And then MLflow projects, basically it is the package of experiments where you can backtrack and reproduce different results that are actually part and parcel of that particular experiment in different iterations. So don't worry, these are all the different components, and we are going to learn about every component in deep in the upcoming lecture. But to give you a high level overview of MLflow, how exactly that would work, so let us see this particular diagram where as I said, like MLflow tracking server, if you take an experiment, so that particular experiment can be associated with different parameters. When I talk about parameters, those are the hyperparameters. And then you can have different metrics like MAE, MSE, RMSE, different things, right? So those metrics, and you have an artifacts associated to that particular experiment, you have a metadata associated to that experiment, and ultimately your goal is to generate a model. So if you run 5 to 6 different iterations, so every iteration is considered as an experiment run, then for every run your parameters can change, your metrics can change, your artifacts can change, and finally your model can change ultimately. So everything can be tracked, and you have a track, and then you can backtrace and then see like which is the best thing that I can choose. And once you have a best model, I can push them. As I said, registry acts as a central place, and then I can push them to some kind of a staging or production, and ultimately from there, using the MLflow model, we can actually give it to the downstream applications. Downstream application could be a third party application or a tool which can actually consume our model and take the advantage of that particular model. So with this introduction of what exactly a machine learning workflow look like, and what are the pain points that are associated inside that particular machine learning workflow, and how MLflow with the components is trying to solve that particular pain points, let us have a small simple hands-on and a small program, and with this we can actually show the capability of uh, MLflow. So for that, let me open my IDE. I am using um, uh, IntelliJ Ultimate, and I have a bare minimum Python project where I don't have anything else here. So SRC, which is empty folder, and I do have a virtual environment here. Now let me create a Python file here, and let me name that as experiment.python. Okay, and now let us start importing different packages or modules. uh, Basically, I've already installed MLflow. The installation of MLflow I'll be showing in the upcoming videos. As I said, this is just an introductory video where you'll understand what exactly is the MLflow and how that would help a data scientist or a machine learning engineer in his day-to-day activities. Okay, import, I'll say MLflow MLflow. It says like it's not there. Okay, let me try to install. Okay, there is some issue. Okay, let me configure that. Or let's do one thing. I'll delete the entire project. Okay, and then let me close this. Just a second, we'll launch. Okay. So let me create a new project. Okay, so it's a Python project, so I'll say hello world MLflow. Okay, and then I have virtual environment which is taken from Python 3.10. Okay, and let's go and create. Okay, yes. Okay, and now let us create a directory which is say src, and then let's say add a add a Python file here which says experiment. Okay, don't ask us, and then cancel, and don't ask it again because I'm not going to add it to the get. And then import MLflow. Okay, now it says not there. Let it install now. It should be quick enough. Okay, it's still installing. Let's see. Okay, I think it is done if I'm not wrong. Indexing. Yep. And then so okay, and MLflow has got a lot of classes. So from MLflow import log metrics. Okay, and then log params, and then log artifacts. Okay, and now let's say if I'll say my module is equals to main. So that means like it's the main code that it's going to pick up and run. With this, like what I'll do is I'll try to run 4 different experiments. Okay, so basic 4 experiments that I'll do in for loop. Okay, for I in range 1 to 5, so 1 to 5 range would be 4. So once I have, so I'll go something with like this, with MLflow dot start run, and then you can pass the run name. Okay, so for every run you can give the name for that particular experiment run. So I'll say this as text underscore experiment, and then finally I'll say str of I. So it would be like experiment 1, experiment 2, experiment 3, something like that. Okay, so I'll just say this even I won't even say test. It should be like experiment 1. Okay, and then with this, what I'll try to do is for every experiment I'll try to give some name. Okay, otherwise I'll say this one as run 1, run 2. I'll say here set the experiment name. So okay, what is this issue? Okay, um okay, let me format. There's some issue. Okay, yeah, no issues. So now I'll say MLflow dot set experiment, and then you have an experiment name, set experiment. So I'll say experiment, and then now say str of I. So this would be experiment 1 2 3, so on so on. Okay, and now if you want to do a parameter logging, so you have a lot of parameters inside your machine learning experiment, so you want to log those parameters. So this is how you should do that. So I'll write a command. So log the experiment experiment parameters. Okay, and that is how it goes. So log params, and it is parameters are always a key value. Okay, so I'll say param hyphen str of 1, and then comma value is I. Okay, so so it takes the key as parameter 1 2 3, how many times the iteration goes on, and the particular value would be the I. And once you are done with parameter logging, basically parameter logging is a key value, so I'll just write it here as well, it's for no confusion, key value. And then once you have parameter logging, then you can log the metrics. Okay, so log metrics. Okay, so metrics would be something like log metric. So you have a key value and the step. So I'll say key value, basically I'll also go for a key value. So I'll say some metric what should I say, maybe like no, I'll directly use our standard metrics MAE. Okay, and then you have I, and then I'll copy this, and then I'll say RMSE, and then again I, and then MSC, and then I. Okay, so I just used our standard metrics like mean absolute error, root mean square error, and then mean square error. Okay, those are the metrics. And then finally I'll say some artifacts. Here I'll try to create one output file, and that output file I'll treat it as an artifact. Ultimately in the regular experiments it would be our model. Okay, so I'll say log the artifacts. So you can do with open, and then say output dot txt, and with the with the write mode, so we will say okay, with open this as file pointer, and then f dot write, and say hello to MLflow, and then finally we just need to know like which iteration this is being written. So I'll say append I, and finally I'll say log artifact of output.txt. Okay, so now with this we are done with the small program, which is the basic primer program, I can say, with different kinds of things that you can track. Basically I am demonstrating the tracking, how we can do tracking inside the MLflow. Okay, let's try to run the experiment. Okay, okay, let us see here. Once you run it, okay, so if you see like there are it says like experiment 1 doesn't exist, and hence it is creating a new experiment. Experiment 2 does not exist, and it is creating another experiment. And if you see here in this current running folder, you have ML runs, and for every ML run there is a hash getting created, and for every hash there are a lot of things like you have artifacts, metrics, params, tags, everything is shown here. So what I will do is we'll open a terminal, okay, and then navigate to src, and then we'll run a command called MLflow UI. Okay, so MLflow UI basically it listens on localhost 5000. So let's try to access this particular folder. And now once you run, so this is the UI, this is how it looks like. And if you remember, we gave the name as run. So you have experiment 1, experiment 2. By default it run, the first time it runs as a default, and then you have an experiment 1, 2, 3 and 4. And inside experiment 1 you have a run 2, and then if you go there, your artifacts, it is recorded and it says like hello world MLflow 2. And then if you go to tag, you can actually attach some tags for this. And then if you go to metrics, like you see MAE, MSC, RMSE, and then the values of those. And if you go to parameters, like you have a parameter with a value, and we did not associate any description with this. So now if you go back to the experiment, so I have all the experiments. So you can think these experiments as a number of times the iterations that you have changed your parameters and you are running it. So you can easily compare what exactly is happening and all those things. So here you can actually add different things, like I want to see the parameters here and all those things, so you can just see them here. So this is the basic usage of MLflow, and you can see here the models as well. Currently we don't have anything, but if you remember my introduction, so you can push that model into staging, production and all, but you will see all those things in the coming videos. So we'll actually take one machine learning problem, we'll associate that machine learning problem with MLflow. We will do it end to end, like by cleaning up the data, and then by dividing that into test train set, and then finally we will validate that and then create a model, and then we'll see like what are the artifacts that get generated and how those all different steps gets tracked inside an experiment. So with this, I hope you got a minimal understanding of what MLflow is and how it try to solve the problems of a data scientist and a machine learning engineer in their daily life. Thank you.